Hey, welcome to lesson 8.5, I think we're on. We're going to be talking about limiting reactants. Um, and basically, what a limiting reactant is when you're looking at a recipe or you're looking at a chemical equation that is a recipe for making something, um, there will be one of your ingredients, one of your reactants, that will run out first. So the limiting reactant is the one that runs out first. So it's basically the one that you um, run out of before any of the others. So it limits how much product you can make. So I think you guys noticed that with those pizzas that you did. You even talked about it a little bit. Okay, so with this many mushrooms, broccoli, whatever, I can only make this many pizzas because it limited how far you could go based on the recipe. Right. Um, so the same is true with the chemical equations. There will be one of your reactants or your ingredients that will limit how much product you can make. And this is how you figure that out. We'll do an example, go back to our s'mores and look at those. And then we'll do an example with some actual chemicals just so you can kind of see how it works. So here's our question here about limiting reactants with our s'mores. It says if you have 3,286 graham crackers and 521 marshmallows and an excess of chocolate squares, so we're not going to run out of those, we know. We don't even have to think about them. How many s'mores can be made? So, unlike the last time we talked about the s'mores, where we just had, if you have this many graham crackers, how many s'mores can you make? Now we have two different ingredients, and one of them is going to run out first. So, we have to figure out A, which one that is, and B, then how many s'mores we'll be able to make. So let me remind you of the equation because it will become important later on. It was 2 graham crackers plus 1 chocolate square plus 1 marshmallow will make 1 s'more. GR2CHM. 2 graham crackers, 1 marshmallow, and 1 chocolate square. Okay, so that's our equation. So the first step in determining which one is limiting, we find the ratio of the two reactants in question, or the two ingredients that we're talking about. So for this problem, the two ingredients in question are graham crackers and marshmallows. So to find this ratio, this comes from the equation. You want to write that down so you remember for later. Reactant 1 is the graham crackers, so 2 graham crackers, 1 marshmallow. So the ratio of ingredients in my recipe, 2 graham crackers, 1 marshmallow. That is what we'll need to make our product or our s'mores. Then the next step is to determine how many of reactant 2 would be needed to react with the amount given for reactant 1. We just label these 1 and 2 based on the order they're in the problem. It doesn't really matter. You could label them any way you want. We'll go in order just because, but. So we'll start with the reactant 1 is what we're given in the problem. The first one we come to is the graham crackers. And we know that we have 3,286 graham crackers. The 1 here is just a placeholder, remember. And then the ratio comes from here, but we need to flip it because I have graham crackers in the numerator here. I need that in the denominator here. So the ratio is 1 marshmallow for every 2 graham crackers. And we flipped it that way because we want our graham crackers to cancel. So we're left with just marshmallows. So with our 3,286 graham crackers, we can make, multiply across here, we get 3,286. Multiply here, we get 2. 3,286 divided by 2 is 1,643. My units is marshmallows. So with 3,286 graham crackers, I can make 1,600 I will need 1,643 marshmallows. this many graham crackers, I'll need this many marshmallows. Don't have that many marshmallows, only have 521. So I'm going to run out at 521. I am not going to be able to use all my graham crackers, which means that marshmallows are the limiting reactant. Marshmallows are limiting. I will run out of them first. Okay? So that's my first thing I have to figure out. Which one am I going to run out of first? Turns out it's the marshmallows. Then I will use the marshmallows to figure out how many s'mores I can make, because I'll run out of them first and that's when I'll have to stop. So this is just like we did the other day. We're going to write a ratio from the chemical reaction, product to reactant, finished product, ingredient. So if we look back, my desired product is a s'more, 1. My recipe is for 1 s'more. And for that, I need 1 marshmallow. So that's a quick, easy 1-to-1 ratio. 1 s'more needs 1 marshmallow. All right. Now, I got to figure out here how many s'mores I can make. Super easy, but we'll write it down anyway. Remember, I only have 521 marshmallows. So I have 521 marshmallows. The ratio is 1 s'more to 1 marshmallow. Multiply, divide, all of these are 1s except for that one. So 521. Oh, marshmallows cancel. Gr2CHM. So I can make 521 s'mores, and then I'll run out of marshmallows. I'll have some graham crackers left over, but my marshmallows limit me, so I can only make this many s'mores before I run out. So let's try an example with some actual chemicals. This is kind of continuing on from that example the other day where we made some ammonia, right? So this time the problem says, what mass of ammonia can be produced in a reaction chamber that contains 1,000 grams of nitrogen and 150 grams of hydrogen? Okay, so my first step is, my screen keeps going blank. Hang on. Okay, there we go. I cannot use grams. Right, I have got to use moles because my recipe is written in moles. So the very first thing I need to do is to convert the nitrogen and the hydrogen both to moles. So I do that with these little, that comes from the periodic table, right? So what I'm given when I'm talking about nitrogen is 1,000 grams. And then the molar mass of nitrogen comes from the periodic table. Remember, this nitrogen is N2. So we're going to do 2 times 14, which gives me 28 grams per mole. Except I want grams in the denominator, so they'll cancel. 1 mole of nitrogen weighs 28 grams. Okay. So when I do my math across here, first of all, the grams cancels. 1,000 times 1 is 1,000. 1 times 28 is 28. 1,000 divided by 28 is 35.7 moles of nitrogen. So here's my moles of nitrogen that I have from my problem. 1,000 grams, that many moles. Now we do the same thing with hydrogen. I'm given 150 grams of hydrogen. The molar mass from the periodic table, if you look that up, is 2 grams in 1 mole. Remember, I want grams in the denominator so that they cancel. And I end up with 150 divided by 2, which is 75 moles of hydrogen. So I have 35.7 moles of nitrogen. I have 75 moles of hydrogen. Okay, so that's the first step. I have to convert it to moles because my recipe is written in moles. And remember, the recipe was 1 nitrogen plus 3 hydrogens forms 2 ammonias. Look back if you don't remember, but that's what it was. 1 nitrogen, 3 hydrogens, 2 ammonias. All right, so now that I have this converted to moles, I need to find the limiting reactant. So I find the mole ratio of the two reactants, which reactant 1 is nitrogen, it's 1, right here, and then hydrogen is 3. So 1 nitrogen needs 3 hydrogens in order for my recipe to happen. All right, so then, just like with the s'mores, I determine how many moles of reactant 2 are needed to react with reactant 1. So reactant 1 is my nitrogen just because we're going in order. So I add 35.7 moles of that, of N2. And then from my ratio, I want 1 mole of N2 down here, nitrogen, 3 moles of hydrogen here. My nitrogens cancel. 35.7 times 3 is 107.1 moles of hydrogen needed. Do I have 107 moles of hydrogen? No, I only have 75. That means I'm going to run out of hydrogen first. I don't have 107, I only have 75, so it will run out. So, like it says here, because you only have 75 moles of hydrogen, not the needed 107, to react with all of the 37.5 moles of nitrogen, hydrogen is the limiting reactant. I will run out of it first. I need 107, I only have 75. So I will run out of it first. Okay. So, limiting reactant is hydrogen, which means I got to work through this problem with the hydrogen, because when it runs out, I'm done. So how much ammonia can I make? Depends on the hydrogen. So when it runs out, I'm done. So that's what we'll do here. So first, my ratio. 2 moles of ammonia can be made from 3 moles of hydrogen. Okay, so the product, ammonia, I can make 2 moles from my 3 moles of hydrogen. So that's my ratio, 2 to 3. Now, I just fill in my problem. Right, I am given 75 moles of hydrogen. Right, that's what I'm given. My ratio is 2 ammonias to 3 hydrogens. I can make 2 ammonia molecules with 3 hydrogens. So my hydrogens are going to cancel. Then in this box right here, I want the molar mass of ammonia to convert that to grams. So I'm going to put here 1 mole of NH3 is 17 grams of NH3. Ammonia is 14, or nitrogen is 14, and then 3 hydrogens, 15, 16, 17. So this will help me convert back to grams so I know how much ammonia I can make. Those cancel. 75 times 2 times 17 divided by 3 gives me a total of 844.7 grams of ammonia. So with my 1,000 grams of nitrogen, 150 grams of hydrogen, I can make 844.7 grams of ammonia with my hydrogen running out first. But that is how much I can make of that ammonia.